Hello and welcome to Auten Math. In this edition, we're going to do some practice with geometric sequences and series. So remember that we defined a geometric sequence as one in which there is a constant ratio between consecutive terms in a sequence. So the first question asks us to identify whether the following sequence is geometric and to explain why or why not. So remember, the common ratio, the constant ratio, is the ratio between one term to its preceding term. So in this case, my constant ratio is going to be 10. And in this case, it's going to be 10. In this case, it's 10. And in this case, it's 10. So I can see, based on the sequence, that my ratio is going to be common between one term and its subsequent term. Remember that R then is equal to 10. It's not equal to one term to its subsequent term, or 1/10. So I see my common ratio is 10. I can say that this is a geometric sequence. The next question asks us to write a rule for the nth term of the geometric sequence and then find a sub 8. So remember that our rule or formula for a geometric sequence is a sub n is equal to a sub 1 times r, the common ratio, to the n minus 1. So let's figure out what the rule is first, and then let's find a sub 8. So I have a sub n is equal to a sub 1, which is the first term in the sequence, or 5,000, times my common ratio, 500 over 5,000 is going to be 1/10, right? So it's not going to be 10 now, it's 1/10. Or I can say 0.1 to the n minus 1. So now I want to find out what a sub 8 is. A sub 8 is equal to 5,000 times 0.1 to the 7th. Okay, so now I need to break out my calculator, and I work out the problem. 0.1 to the 7th times 5,000 leaves me with 5 times 10 to the negative 4th. Okay. In the next question, I'm asked to write a rule for the nth term of the geometric sequence that has the two given terms. Now, there are a couple of ways to do this. One is you can kind of eyeball the ratio and try to figure out what it might be. But the problem with eyeballing is that when the spread between the terms gets larger, let's say now I have a sub 2 to a sub 5, I only have 3 terms in between the two. What happens if I have a sub 2 to a sub 100? Then you're going to be in trouble. There's no eyeballing there. What you want to do is to figure out a process to determine the ratio in a sub 1. So let me walk you through that process. Well, I know that the rule, again, for a sequence, geometric sequence, is a sub n is equal to a sub 1 times the common ratio, constant ratio, to the n minus 1. So I can write a sub 2, which is going to be 2, is equal to a sub 1, which I don't know, times the common ratio, which I don't know, to the 2 minus 1, or 1. Well, this I can rewrite in terms of just a sub 1. It's a sub 1 is equal to 2 over r to the first, which is just r. So now I'm going to take this value for a sub 1, which is defined in terms of r, and I'm going to substitute it into the equation that we're going to create for a sub 5. So here I have 16, which is a sub 5, is equal to a sub 1 times r to the 5 minus 1, or r to the 4th. Well, what I'm going to do is I'm going to take this value for a sub 1 and I'm going to plug it right in to this value for a sub 1. So I get 16 is equal to 2 over r times r to the 4th, which is the same as 16 is equal to 2 times r to the 3rd. So now I divide both sides by 2, and I get 8 is equal to r to the 3rd. Now r is equal to 2. I take the cube root of 8. Cube root of 8 is 2. So now I know that my common ratio, or my constant ratio, is 2. I can find out what a sub 1 is. So I'm going to erase this. I know that the common ratio is 2. And so I'm going to rewrite this as 2 is equal to a sub 1 times r, which is 2, to the n minus 1, 2 minus 1 to the 1. So I have 2 is equal to a sub 1 times 2 to the 1, which is 2, or I have a sub 1 is equal to 1. So now I can figure out my rule. A sub n is equal to a sub 1, which is 1, times my common ratio of 2 to the n minus 1. So we went through a process of identifying a sub 1 in terms of r, and then substituting that value in for the other equation that we had, and finding out what r was, and then using that value for r to define what a sub 1 was. And once we have both a sub 1 and r, then we can write our rule. Okay, in the last question, we're going to find out what the sum of the geometric series is. And we're going to use the rule that we learned before, which was the sum of a geometric series is equal to the first term times 1 minus r to the n over 1 minus r. So we know that we're looking for the sum of 8 terms. So we have s sub 8 is equal to the first term. The first term is just the value that I get when I plug in 1 for I. So if I plug in 1 for I get 2 to the 0, which is 1. So 1 minus 1 is 0, 2 to the 0 is 1, times 0.5. So a sub 1 is just 0.5. Times 1 minus r, which is the common ratio, it's 2. And notice how this entire rule looks very similar to a sub 1 times r to the n minus 1. Okay? So they give us the rule of the sequence, and they ask us to find the sum. So I see my common ratio is 2, right? Common ratio is 2. And I raise that to the nth power, which is to the 8th. And I take that over 1 minus the common ratio. So I break out my calculator. I find out what 2 to the 8th is. 2 to the 8th is equal to 256. So 1 minus 256 is minus 255 over negative 1, which gives me 255, times 0.5, and I get 127.5 as my answer.